Thank you, Ben. Oh, okay. So I'm Nithin, and this is my colleague Sai, and we've been working on porting Open vSwitch to Windows/Hyper-V for a couple of years now. And we did give a talk about 2 conferences ago, just to sort of announce the initial port. We have made quite a bit of progress since then. Today we'll be giving updates about that, and also we'll pick a couple of big ticket items that we have worked on and give more technical details about it. So the agenda is quite simple. We'll provide you some introduction and also provide you some architecture as a background. And the big ticket items, as you can see from the agenda, are Stateful Firewall, coupled with a demo for it, and also container support. And then we'll talk about roadmap and questions. So Open vSwitch for Hyper-V is a full-fledged solution. It's fully open sourced. All the commits are made on master. We don't have any proprietary implementation or anything of that sort. We've been supporting Windows 8 /Server 2012 plus. We're also supporting Windows 10 and 2016 also. And recently Cloudbase has got it signed also, and we're signed the Windows drivers signed. Got the Windows drivers signed, and we're pretty much making it mainstream. So obviously it consists of 2 portions. There is a user space portion which is ported code, which is common with Linux, but the kernel data path was written brand new. It's an NDIS driver, and if you go to the next. So here you can get a sense of how we integrate it with Hyper-V. Right? Hyper-V, as you know, is Microsoft's platform for running virtual machines, and on my right-hand side here, you can see that there is a Hyper-V switch. And there are 2 virtual machines running, also known as child partitions in Microsoft's terms. And we also have an internal NIC, which is basically a virtual NIC on the host, and also a physical NIC, right? So any packet that flows through the switch goes through the ingress path and goes out through the egress path after forwarding. That's where we come in. So we sort of connect to the Hyper-V switch through APIs that Microsoft provides for third-party vendors to integrate with their switch. They want third-party vendors to sort of extend the functionality and sort of adopt Hyper-V more, right? So that's where we come in. We can connect to the Hyper-V switch, get hold of all the packets that are flowing through the switch, and also we can enumerate the switch to sort of find out what are the ports on the switch, etc. Right? So I'll give you more details in the next slides. So like I said, we are an NDIS driver. In specific terms, we are a filter driver, and we implement the forwarding functionality for the Hyper-V switch. To sort of keep the code as similar to Linux as possible, we actually use netlink messages for communication between user space and kernel through a character device equivalent on Windows. And pretty much a lot of things are along expected lines. One of the cool things we did, in fact, Golan is right here, he did, is we implemented code to sort of do deep copies and partial copies of NBLs. NBL is a packet in Windows terms, right? So the existing API was not great as such. It did shallow copies and no ref counting, nothing. So we've implemented a framework for that, and that has actually bought us a lot of things. So in this slide, we'll talk about packet flow. Like I mentioned, any packet that gets sent out from a VM goes through the ingress path of the switch. That's where we hook in. And we do a flow lookup. If there's no flow, then it goes to user space, goes back into the kernel after the U-turn. And then based on the flow, we can in the NBL, we can say which are the destination ports, right? Or if we need to modify the packet for NCAP and such, we can do that or even drop the packet. So the lower edge here you see of the Hyper-V extensible switch implements the forwarding decision that we specified. Right? After that, it goes to the destination. It'd be a physical NIC or another virtual machine, and then the completion path. Right? That's how the accounting is implemented. So in terms of features, we are we try to keep it pretty much up to date with the OVS implementation itself. On Linux. So we support all of the popular tunneling technologies. This year we basically added Geneve support and also enhanced STT for all of the offloads. The L2, L3 override can be used for things like routing. So we support sampling, recirculation, and we'll talk about firewall next. And recently we also added support for multiple NICs. So basically this is, you can think of it as the equivalent of tap devices. So you can create as many virtual adapters as you want on the host, and we're planning to leverage this for testing, etc. in the future. So, and yeah, so last but not the least, we added support for name pipes. So in some sense, you can see that we're trying to do a balancing act between trying to keep the code as similar to OVS on Linux, but keeping it sort of adhering to the Windows terms or Windows conventions. Right. Now we'll switch over to the next slide. So as I mentioned, we'll talk about a couple of big ticket items: stateful, firewall, and containers. Here's the first one.
Hello, everyone. So one of the fundamental requirements for stateful firewall is connection tracking. And as many of you know, on KVM, the NetFilter contract module lets you do that. Unfortunately for us on Windows, we didn't have anything like that. So we had to pretty much implement our own connection tracking. And while doing that, we actually looked at other alternatives. One of them is the Windows filtering platform that you see over there. It's native to Windows. It lets you create firewall policies, and it also lets you audit the firewall connections to see how many packets have gone through this particular policy and things like that. However, there were two main flaws with that particular approach, or at least that didn't fit into our pattern. One of them was that it wouldn't let us query for the connections as such. So if we wanted to see what's the current status of a connection, we could not get it easily through WFP. And the other one was that it's incompatible with OVS. OVS is more flow-based, whereas in here it's a lot more different. So we couldn't exactly leverage WFP out of the box. That said, the other alternative was the FreeBSD's packet filter. It's free BSD, so we could have just used that one directly. However, the issue with packet filter is that we didn't require a full-blown firewall. Instead, we wanted to implement that using OVS. And while doing that, around the same time that we are looking into it, one of my colleague, Daniele, he ended up porting the user space connection tracker. At least he wrote a new connection tracker for the OVS user space that's being used by DPDK. And I could pretty much port most of that over to use it in HyperV data path. So we do use the contracts, FreeBSD's contract TCP parser. That's the only thing being used right now. And so we are still adding in support for more stuff. Apart from that, we also support a familiar netlink interface. So you can pretty much query any of the contract things very similar to how you do it on KVM. So we'll be going over the architecture here. In this case, the contract module is internal to OVS, unlike KVM. So when a packet comes in to the OVS data path, the packet does not have any connection tracking state. It's set to a not tracked bit, and then it goes through the flow table, and where we decide that the action is going to be contract action. So this is something new that we had to implement, similar to KVM again. And once the packet goes through contract action, it goes along to the contract module, where in the contract module, we parse the phi tuple of the packet, and we check out the connection tracker to see if it's a new connection or an established connection, or if it's one of the related connections. And once we have that, we actually end up updating the flow key in the contract module itself, because it's internal to OVS, and then we send the packet back to the float lookup. So if there is any matching flow, we end up executing that particular action. If not, it gets sent up to user space, and from there, it's business as usual. That said, the user space currently supports OVS dpkernel dump contract and flush contract, and it's done using a very similar netlink interface. Even though it's sort of pseudo, it's not exactly native to HyperV. We do support that one. Internally, it's implemented as an expirable map, if you think about it. So every time a packet comes in, we parse out the phi tuple, and then we either commit that particular entry, or we just let it go. Then we also maintain the size and the number of packets that we encounter per connection, so that we can always extend on top of it. We can track anything else that we need. Like I mentioned earlier, we do support dump and flush right now. One new thing that we did decide to add in was for subscribing to events. So every time a contract entry gets created or deleted, we'd like to send up that particular event to the user space, so that if you have a different agent that's listening for these events, it can subscribe to it. One additional thing that we'd like to add is updating a contract entry. So currently, we don't support it. However, if you could update an entry, we'd want to rope that in as well. As it stands, we support ICMP, UDP, and TCP packets, IPv4 packets. We'll be looking at adding an IPv6 support and other fragmented packets and ALGs. this, we're going to switch over to a demo. Thanks to Cloudbase, who actually gave us this particular video. In here, just to give you an overview, we'll be running Hyper-V and KVM on an OpenStack setup and enable stateful firewall rules on it. So as you can see here, we are now setting up DevStack node, which is pretty much setting up OpenStack, to those of you who are familiar with it. This is pretty straightforward, just the OpenStack ones. OK, so now that we have OpenStack up and running, we are now going to set up the Hyper-V node as a compute node. And for this, there is a Cloudbase installer, which they have provided on their website. You can use this to set up OpenStack on Hyper-V, or rather have Hyper-V connect to OpenStack node. After this, they're installing OVS, which is from the master branch. That's nothing different. They don't have any proprietary patches as well. Once this is done, they're now going to configure the Neutron OVS agent, just like how you'd configure for KVM. It's just spot on, simple. They have a blog post on their particular website as well as to how to set it up. It's pretty straightforward. All you have to do is just copy a few conf files, make sure things are enabled properly. And over here, you would probably see them enabling the firewall policies right about any time now. It's a pretty fast video. So, OK, so they're just setting the firewall driver to be open vSwitch instead of IP table, because it's just going to use contract under the hoods. Okay, with this in place, the next thing that the demo is going to show is creating VHDX images. I think for KVM, you use QEMU, and then for ESX, there's a different format. For Hyper-V, it's called the VHD, or the virtual hard disks. So in here, they're now going to be spawning two VMs, one for KVM and another one for Hyper-V. Okay. The next thing is he's going to be setting up the security groups for both of these VMs. There's going to be one security group for a KVM VM, another one for Hyper-V. And once that is there, that you'll pretty much be tweaking the values in there to create the stateful rules. Sorry, stateful firewall rules. As you can see here, he just set up the default SSH rules so that you can SSH into these two VMs and then run ping and TCP traffic from there. The PowerShell window is going to represent the Windows VM, and then the putty one is going to be for KVM to keep things pretty simple. And he's just running OVS vSCTL show to show the port that got created, this particular guy. So running ifconfig on both. He's going to be showing us the ICMP firewall. So he's trying to run ping from the Windows VM to the KVM one. And as you can see, the ping is currently getting dropped, which is visible. Okay. It was visible earlier, but that's fine. Now he's going to be setting up the ingress and egress rules for the ICMP traffic. Once that is set up, it's going to get the ping is going to start working immediately. Next, he's going to try doing the same thing from KVM back to Hyper-V, just to show that ping works across in both directions, and there's no checks and bugs or anything like that. So now that ICMP is out of the way, the next thing that he's going to demonstrate is for TCP traffic. He's going to open up two ports on port 2000, and then demonstrate the traffic. And similarly, the rules for both the ingress and egress on Windows first, and then the ingress and egress on KVM next, or vice versa. And we'd really like to thank Cloudbase for setting us up with this particular demo, because they're not here to represent the whole thing, but it's really nice of them to actually provide this one. Okay. Oh yeah, so this also shows that Hyper-V and KVM today just works on OpenStack. So all you have to do is just download OVS from master, and then it works right out of the box. No proprietary patches or anything like that. The last thing here is going to be the UDP traffic, just to show that all three of them work, and I wasn't bluffing. Okay. That said, I would like to hand it back to my colleague for the next demo. Oh, sorry, the next talk regarding containers.
Thank you, Sai. That was a pretty cool demo. Okay, so that was one of the big items that we worked on in the past year. As you can see, it's sort of fully integrated into the ecosystem. So next feature that we're going to talk about, it's not fully open sourced yet, but the Cloudbase guys were kind enough to provide all the technical details of how they're doing this, and with the promise that they'll be open sourcing it soon. And they've also sent us a short demo. Right. So as we know, Microsoft has also announced support for containers starting from Windows 10/Server 2016. I mean, not just containers, but they would also be supporting the Docker interface, meaning the Docker client can connect to it and manage it as though it's a Linux box. Right. So there are two container types. One is a Windows container. The other one is a Hyper-V container. Windows container is similar to the Linux way of doing things, where it's more like OS virtualization, where you have where you don't really create a full-fledged virtual machine as such, but you sort of implement isolation with within the operating system, right? So and as you can guess, it does not really require the Hyper-V feature enabled as such. And Hyper-V container is more akin to a traditional virtual machine setup, where you need virtual machines and you have only that container running in that virtual machine, right? Obviously, you're not going to be running a full-fledged or a heavy virtual machine. Microsoft has optimized this workflow to create a lightweight virtual machine. In fact, I think they've also announced something called as Windows Nano, where they can run thousands of these highly optimized containers, right? So we're not talking about Nano yet. And as soon as you enable the containers feature on Windows, they have sort of decoupled this switch, the switch functionality, right? Earlier in the diagram, I showed you that there's a Hyper-V switch and OVS attaches to it, and that Hyper-V switch was available only when you enable the Hyper-V feature. But now that switch, they call it a VM switch, it's available when you enable the container feature also. Right, so pretty much whether you're using a Windows container or a Hyper-V container, they end up creating a virtual interface somewhere, and this virtual interface has a leg in the VM switch. We have also noticed that there's also a NAT service running on the host, and the NAT service has a leg in this VM switch. That way, containers can sort of get networking into the physical world or the outside world. So. I mean, a lot of this is obviously observed behavior. We don't have a lot of technical details, but this is what we know. We've seen that with the Windows container, basically there's a virtual adapter that gets created. And this virtual adapter is not really visible on the host. So if you run ipconfig or go to the list of adapters on the host, you don't see it. But if you look in the properties of the adapter, when you actually capture it on the switch, it shows type internal, and internal they've traditionally used it to represent a host adapter, right? So the story is different when you talk of a Hyper-V container. Hyper-V container, as I said, is more akin to a VM form factor. So the type of port shows up as a synthetic port. Synthetic port is their paravirtualized port, right? So, but regardless of what it is, the cool thing is OVS as is works with that. So as long as we have OVS enabled on the Hyper-V on the VM switch, regardless of what container you're using, we can pretty much enforce a policy and all that, right? So, and obviously the policy that we'll be enforcing in the demo is that we'll just forward the packet to the third port on the switch, which is where the NAT service is running, and then the NAT can send it out to the physical network. So in this demo, so we can see that we just ran get VM switch, and we can see that there's a switch called NAT, right? That's what they call it. And we see that there's a HNS internal NIC. This is where the NAT is listening on the switch, right? And we can see that OVS is enabled on that particular switch. And if you run OVS vsctl, you can see that this port has been added to OVS-DB, which means OVS can manage the traffic coming from that port. On the top left side, we're going to run a HyperV container now. Oh, sorry, Windows container. And as soon as you run the Windows container, you see that there's a new port that got added called the container NIC. And then we also ran a Hyper-V container, and a new port got added with the UUID. So these are sort of the things that Cloudbase is actually working out to sort of smoothen the workflow, and that's why they're not open sourced it yet. And obviously the command we ran was cmd in the container, and we got a shell. From there we can run ping to the outside world. So the 172 IP you see, oh, not yet see, okay, we'll see it in the flows. So we are actually reaching out to the internet, but if you look at flows here, you'll see that there are IP addresses in the range of 172, etc. So these are all the static IPs that Hyper-V or Windows configured for the containers. And you can see that the output port is actually 2, which is where the NAT is listening. And that sort of concludes this demo. So, and again, this is not open source yet. But actually earlier this week, we spoke with Cloudbase, and they're waiting for a few technical details from Microsoft in terms of like assigning port names and such. Once that gets worked out, they're going to open source it. So, so far we talked about 2 big ticket items we worked on this year, but we have a few more things coming up. One of the pain points that we have seen is that if you're using OpenStack, everything is cool. But in terms of configuring OVS, adding ports to OVS, etc. But if you're running OVS standalone, it's a pain to actually add ports to OVS-DB. I mean, it's not a pain for running OVS vsctl, but it's a pain to sort of assign names to the ports, right? So one of the things that we are working on is on a daemon that will run only for OVS Windows, which will basically, whenever a new port comes up, and is connected to the Hyper-V switch, will assign name to it and also auto-add it to OVS-DB. Pretty much similar to what libvirt does in terms of OVS integration, but we'll write a daemon just for this purpose. So this will actually ease a lot of things. And we are also, Sai is actually working on ALG support for contracting, which we don't have yet. And IPv6 is also on the works. So we haven't really gotten time to work on a lot of performance-related stuff. That's why we don't have mega flows yet. But hopefully we'll have it soon. Then containers, I already sort of gave you a preview. And one of the things we have seen is that if we use something like STT, we can pretty much leverage TSO that's natively available. And recently Microsoft added support for VXLAN also. But we have new tunneling technologies like Geneve that Microsoft doesn't support yet. So we'll try to work with them to sort of add native support for all this and expose this in end so that we can leverage it from OVS. And QoS and also OVN support is kind of in the works, but we're not actively working on it. If anybody wants to contribute, you're more than welcome. So we meet every Tuesday at 10 a.m. Pacific time on the vSwitch IRC channel. You can always join and have fun. And with this, we'll open it up for questions. Sai and I are here, and we can answer any questions.
Yeah, we have time for questions, so please come up to a mic if you have something to ask.
I have just a few questions. I think you had it in the first slide, but just to understand, how much common code is there between the Hyper-V port and, say, the Linux port?
Yeah. So, okay. So the dark green or the all of the user space code is 100% common.
Okay, so it's basically like
yeah.
Kind of
so in fact, we use the same DPIF also.
Okay, and then another question I have is, presumably Hyper-V already has a virtual switch, so how does it compare in terms of functionality and performance? Kind of what's the value? Why would you use the OVS one?
Sure. That's a good question. So Hyper-V native switch was not very rich in terms of functions so far, right? But with Server 2016, they've added a lot of features. In fact, they've also made their switch programmable through OVSDB, right? But this is in 2016. But when we started working on this, we were working on Server 2012, and it did not have a lot of features. For example, firewall support, all these things were not there, right? So obviously there was value in plugging in other types of switches like OVS to the Hyper-V switch and enhance the functionality. And even though Server 2016 does provide programmability, it may not work with all of the SDN solutions out there, right?
Okay,
so there's still value.
And then last question is, there's been a lot of talk the last couple of days about like programmable data planes, P4, BPF. Is that something you guys are looking at, or thoughts about how you
Not actively. In fact, Ben and we were talking last week about this. We will be taking this up, but not actively yet. It's under discussion.
Okay, thanks.
Thank you. I can hear you.
Really do. Okay. I was saying that I'm excited probably for different reasons than
we are excited too.
OVS and containers on Windows, then you can make a native Windows mininet, which is pretty cool. I'd encourage anyone who wants to do that to take it on, because it'd be really great. But for running OVS on Windows, it seems like there's another option besides running it native with Hyper-V, which would be running OVS on top of Ubuntu for Windows. And I wonder, if you would compare those two, and how do they compare in terms of functionality and performance? Because I think that would be a really nice thing to have as well, and presumably it should work.
What was the first part? What's the alternative you said?
So you described OVS for Hyper-V and native Windows, which is great.
Yes.
But as you know, Microsoft with Windows 10 announced Ubuntu for Windows, which is basically kind of a sort of, I guess you'd say, a kernel compatibility DLL that allows you to run Linux binaries and, in fact, just run the whole Ubuntu operating system, except for the kernel on the Windows kernel, which is really neat. It's like, Linux on top of Linux with a Windows kernel, and you can just run all the binaries and apt-get everything. And presumably you can, if not now, in the near future, hopefully, run OVS on Ubuntu for Windows as well. There are lots of reasons why you might want to do it. And I wonder if you could compare and contrast, like, sort of functionality and performance of these two approaches. One is sort of, which I think are both valid and useful. One is sort of native OVS for Windows and Hyper-V, and the other is sort of the Linux OVS running on Ubuntu for Windows.
Sure. So, I've not looked at all the technical details, but I think what you're saying sort of relates to all the Bash announcement also that Microsoft made, that they'll be supporting Bash in the future.
Precisely. Bash is, I don't think there's a native Bash.
They said they'll work on it.
Oh, okay.
Yeah.
So as far as I know, the Bash that I've seen on Windows 10 has been running Bash on Ubuntu for Windows rather than Bash on. It's not entirely clear that Bash really makes sense for Windows, but I guess you could run it.
Yeah. Anyway, so sure, that's actually cool. In fact, that will probably make a lot of Linux developers love Windows for whatever reason, right? So, but that said, regardless of whether, all these Ubuntu DLLs will probably provide you a very similar interface on Windows to user space, right? But the key thing here is, if you look at the box here, all of the user space stuff, it's fine, but without the kernel data path, you cannot really get access to anything. You need an entry point, right? So without that entry point in forms of a kernel driver, you cannot really get access to packets coming from containers or whatever. That said, if Microsoft has some alternative container stack which comes with this Ubuntu DLLs, yeah, sure, maybe we can get access to packets.
As I understand it, Linux containers are supported on Ubuntu for Windows, as I understand it.
Okay, I don't know all the technical. If there is, then sure, maybe. I don't know all the technical details.
So, Bob, if you want a little more information, the first episode of the OVS Orbit podcast was an interview with Alessandro Pelotti from Cloudbase, and we talked a little bit about Ubuntu on Windows and how it relates to OVS.
Great, thanks.
Thank you, Ben.
I was going to say, just quickly, so for what it's worth, we tried to run this with the Windows 10, with the Bash, and so on, but I think the kernel interfaces are not as complete. So Sure, if you want to do some Linux user space application, then probably all the APIs are there. But when you want to try and do something around like networking, something more integrated with the lower level pieces of the kernel, then that's not close. Obviously, Microsoft could do something if they really wanted, but who knows? Yeah.
You phrased it better than me. Thank you, Joe.
All right, one more question.
These are two short, stupid questions. So will this run on anything other than Windows Server in your strategy, or is it specific to Windows Server? Like, will it run on Windows 10?
Yeah, of course.
Okay,
so
it's on all Microsoft platforms.
So if you go back one slide, so basically we say that this is compatible with Windows 8 or Server 2012. The way Microsoft has implemented Hyper-V feature is that you can pretty much take any desktop grade OS and you can enable the Hyper-V feature, right?
And resource usage, do you
Yeah,
envision it being
I was going to get to that, right?
So the first one, and I forget my second one, so I'm done.
Okay, sure. Okay, thank you all.
All right, let's thank our speakers.